Okay, hi everyone, and welcome to Data Anonymous virtual event introducing Kafka Connect and custom connectors. My name is Dai Yafe from Nielsen, and I'll be moderating this session. This is the first time we're hosting such a virtual event, so we hope it will go as planned. Today, Kobi Hikri will give a short intro to Kafka Connect, and then show actual code example of developing and dockerizing a custom connector. Kobi is passionate about software systems in general and distributed systems in particular. As a software design and architecture consultant, he has designed and implemented large-scale systems, and he loves to talk about it. So take it away, Kobi.
Okay. Hi, everyone. Thank you for joining to this introducing Kafka Connect and implementing custom connectors session. This talk is has a bit of a background about what is Kafka Connect and what it provides us, what we can do with it, when is it suitable for our needs, and when it might not be. And then we will, this is going to be a short intro to this talk, and then we'll do everything hands-on and simply implement a Kafka Connect cluster in Docker and go and see how we can work against it using the REST API. And eventually we'll develop a web page links data source, meaning a web crawler. We'll implement it and see how we can install it in our cluster. And then if we'll have additional free time, we'll also implement a sync connector to consume this data. And we'll leave some time for Q&A at the end. And eventually, if there will be additional interest in the group, we can dive into more advanced topics in a following talk. So that's basically what this talk is going to be about. It's about an hour and a half or a bit less. So let's get started. In this talk, we are going to talk at the beginning about what is Kafka Connect. We will talk about the world of data as it is today, and most of you guys are experiencing it daily and are noticing that things have shifted. It's not a single database anymore, a simple developer world where you only knew SQL and worked against a SQL database or an Oracle database. Things have changed. Our data sources have changed. We'll talk about why we need Kafka Connect. When will we consider using it? And then we'll get to the part about how to work with Kafka Connect, which will be most of this talk. We'll see how to set up the infrastructure, how to interact with our deployed cluster, and how to implement a custom source connector. And then we'll see how to work with the REST API. We'll basically all the interaction with the Kafka Connect cluster and deployment and status checking will be done with the REST API. And what we will not cover in this talk, but I am open to doing it in a follow-up session, is Kafka Connect transformations, which is a notion about mutating data as it is being received, which is, I consider it a bad practice, but if you want to go into it, then I can go into it. And working with custom schemas, which is a big topic, and I will mention it where we get to the point of sending and receiving the data, but it deserves a whole talk of it on its own. So it's not going to be fully covered in this talk. Okay, so what is Kafka Connect? So basically, it's a Kafka integration tool. That's what we need to understand. It's a tool which is meant to be used in a domain where we are using Apache Kafka, whether it is a vanilla implementation or whether it's the Confluent implementation or the Lenses implementation. It's centered around Apache Kafka. It uses its capabilities and extends on it. And that's the most important thing to understand. It's a Kafka integration tool. It allows us to import data into Kafka and export data out of Kafka. Kafka Connect runs as a cluster of one or more system processes. Each process is referred to as a worker. Now, you're going to notice, some of you that are coming from the world of Storm, and you will see that the terms here and the grouping and everything is very similar, because some of the main contributors to the projects are the same people, by the way. So we are saying that each such process, we call it a worker. Workers are grouped together in worker groups. And we have connector instances that are managed by the Connect cluster. Each connector has tasks, and our tasks are configured by connectors and distributed across workers. The workers are taking care of making sure that that tasks are at the desired parallelism that we defined, and if someone dies, then they will take up, and then they will take up a new one. And then we are going to the last abstraction layer, which is data pooling and pushing. Data is being pulled by source tasks, which are configured by source connectors, or pushed by sink tasks, which are configured by sink connectors. Now, one short word about the world of data today. You all know it, but keep in mind there are a lot of definitions out there. There is no official definition for the world of data or data at all. And I like to think of it as the book, if you remember from those of you that studied the physics, then there was this very famous book by Halliday and Resnick, Fundamentals of Physics. And what they did there was very nice. At the beginning of each chapter, they had a what is physics definition. And per this chapter, they gave a definition for physics. Now, what we are doing today now in this talk is something similar. And I'm defining data, the world of data today, as a world where data is scattered all over. We basically need a jigsaw and plenty of glue to create our own data that our company or our enterprise or our users are interested in. We need to glue it for them. We have so many sources for data and so many ways to represent and ship it to users that we need to just create our own puzzle per client. And you probably all feel it in your day-to-day work. Okay, so why do we need Kafka Connect? This relates to the previous slide. And in one word, integration. Kafka Connect is all about bringing different data-oriented technologies together, about connecting things that are not that aren't able to connect natively. We want to connect a new data source with a new technology or a proprietary technology, and we need some way to pass this data around into Kafka. And I remind you, it's a Kafka-centric technology. We want to pass this data in Kafka and analyze it. So we need to, when we want to do it, we need to consider that we have so many APIs for different technologies and communication protocols that it's really impossible to have these integrations built into Kafka. So we need an integration layer so we can implement the specifics we need as we need them, as in an ad hoc manner. So, and in more than one word, if I said that in one word it's integration, then in more than one word, we also want to make sure that our integration layer is fault tolerant and scalable. Because when we are bringing data from this wild west of sources and sinks of data, we want to make sure we don't lose anything on the way, or that we lose the fewer data as we can. So we want to rely on a fault-tolerant and scalable and mature technology such as Kafka. And Kafka Connect leverages a lot of the capabilities of Kafka. It's based on them to make sure that we can scale our pipelines and not lose our data if something breaks. So when will we use Kafka Connect? So I will generally say that if we are able to implement a Kafka producer and consumer within the technologies, then we might not need Kafka Connect. We could just produce our data into Kafka topics and then consume them from other Kafka topics. That's if our needs are very, very simple and we are not expecting a very high bandwidth. But in many cases, I would risk saying most cases, implementing a Kafka producer or consumer within the endpoints, within the technologies is impossible. We usually don't have the source code. We cannot have, if we want to crawl a website like we're going to do in a few minutes, then we cannot plant a Kafka producer in the web server's hosting machine, in the web server service itself. We cannot do it. We don't have the source. And sometimes we do have the code, but it's very expensive to modify it. For example, we are writing in a coding language, and we don't have a native Kafka producer for this language, and implementing one could be very, very expensive. Or if we have a system that is it's already in legacy mode, and every time we touch the code, we break something, it's very untestable. So in these cases, using Kafka Connect would be a natural choice to integrate externally. The other case is, even if we have the source code, and even if modifying it is very cheap to do, and we have a Kafka producer and consumer drivers available for us, and they are up to date, then sometimes it won't be feasible because the bandwidth we desire will be limited by the hosting process, which creates the consumer or the producer. So in these cases, we would like to take out the integration components and make sure that they are able to receive more resources for producing or consuming this data. Okay. So this was me talking about Kafka Connect, and the slide part is done. And what we're going to do now is open the code and start seeing some stuff, because that's the way people learn the best, I think, especially practical people. And what we're going to do in this demo is bring up an infrastructure, a Kafka cluster in Docker Compose. Then we'll add Kafka Connect to it. We will examine how we can use Kafka Connect's REST API, and at the end implement a custom source connector. And if we'll have time, then I will also show implementing a sync connector to consume the data of the incoming source connector. Okay, so let's get started. Let me just skip here. And can everyone see my screen? Just if someone can say yes, then
yes.
Okay.
Yes.
Okay. So what we're going to do in this demo is, first of all, I'm not going to show how to bring up a Kafka cluster, but I'll just mention that in this compose file, in this Docker compose file, I have a Kafka cluster which comprises of a Kafka broker and a Zookeeper. This is the vanilla Kafka. Okay, I'm downloading it from it's an official Kafka release. It's not any specific company, and it's configured. It's configured per the documentation. You can follow it. I can also provide this compose file at the end if you guys want to play with it. And then on top of this cluster, we are connecting a Kafka Connect cluster to it and exposing its REST port, its REST API port. I want to show you the Docker file so that you'll believe me that it is the vanilla Kafka version. This is Kafka 2.5.0. All I'm doing in this Docker file is I'm taking the JRE Alpine, OpenJDK JRE Alpine version, and then I'm just installing wget and downloading the official Kafka version. And then I'm doing something magical here, which I will explain shortly, configuring the broker and running it. But let's see what I'm doing here. Kafka Connect is basically, if you just bring it up, it will not have your connectors, right? You didn't still ship any custom connector to it. What I'm doing here is I'm telling Kafka Connect, not Kafka Connect, I'm telling my Docker file, I'm saying, take whatever is in this compiled connectors directory here in Kafka Connect, take whatever is found here and copy it to the bin compiled connectors directory in the container. Okay, so now you see this directory is currently empty, but we'll see that after we implement our connectors, we'll see that as part of our build process, we are delivering the output to this folder. And then when we are building our Docker image, then we are copying the connectors into it. Eventually, in order to start the Kafka Connect cluster, I'm invoking a script, configure and run, and inside it, I'm copying it into the image, okay? And then I can make sure that before I invoke Kafka Connect and start it by calling the command connect distributed and passing it properties, configuration properties, then I'm first populating the properties file. I'm first telling it the most important thing is, hey, here is your Kafka cluster. Use it by connecting to this Bootstrap server. Okay, this is the Kafka server that I declared here. Its name is Kafka. The host name is Kafka. So I'm telling my configuration, write your Bootstrap servers, Bootstrap against the broker Kafka at port 9092. The group ID for this Connect cluster will be Connect cluster. I know it's not the best name, but this is also, by the way, this is the default value that is in the Connect distributed. If you do not provide it, your cluster name will be Connect cluster. Then I will come back to the converters immediately, but then we have the plugin path. I'm telling my container that look for additional plugins in this folder, bin compiled connectors. And I remind you, if we go back to our Docker file here I copied into the image the contents of this folder. I made sure that it will be there when a container is started from this image. Okay, so once I put files here, then they will be configured, they will be copied into the image, into the bin compiled connectors. And when I'm starting the container will be configured, Connect will be configured to read the plugins from this folder. So this is the way that this is my build process to make sure that when I'm creating connectors, they are delivered into my Dockerized environment and then pointed at by my Connect distributed process that is being started. So, by the way, in the plugin path, you can provide multiple paths, and for the sake of simplicity, I just used one. Let's get back at these configurations. They are very important. They also have default values, but it's very important to understand. And I will now I will try to touch on a problem that a lot of people are experiencing, the data conversion problem when they begin with Kafka Connect. But it is something that if you understand it well, you will experience less problems. So Kafka Connect is, as an integration service, relies on an existing Kafka cluster. Now, it might be the case that you are writing into a topic or reading from Kafka topics that were already created. It's not your topics. It's not topics that you can do whatever you want with them. So in this case, you will have to provide what is called a converter class. It's really a class. It's a Java class, and tell Kafka Connect what to do when he serializes and deserializes data when working with these Kafka topics. So in our case, we are going to use JSON. So I'm telling Kafka Connect that the key that when he writes something into Kafka, into the topics that we're going to write to, then to convert the key to JSON, and when he reads from it, to convert it from JSON. The same thing is about the value. I'm telling him, make sure that when you write something into the value field in the message, then write it convert it to JSON when you write the topic. Now, keep in mind, obviously, everything in Kafka topics is stored as bytes. Kafka doesn't know about our types. So this is our way to convey to, when we are writing the key and value converter, this is our way mostly to work with. It's for developers. It's not for Kafka. Kafka doesn't need this knowledge. Kafka can take whatever you throw at it. You throw byte array at it, he will manage it. He will pass it to the other side. So we'll see when we consume data in a few minutes, then we will all see that how this data comes out, and you won't be surprised now when you'll see that we are writing data, we are writing a string, and then data comes out as JSON, in JSON format. So now you understand, you'll understand why it happens. Okay, so at this point, we now understand that we have a Zookeeper and Kafka instances, which makes our Kafka cluster. And then we now talked about how we can bring Kafka Connect up, connect it to our Kafka cluster, and configure it. I also did something here for in case we want to investigate the logs. So I installed the Elastic Stack. I installed the Elasticsearch Kibana and FileBit to collect all the logs into Elasticsearch so that it will be easier for us to search. And I also installed a tool called CMAC, which is a Kafka administration tool. It was initially developed by Yahoo and it was recently renamed to CMAC. It was called Kafka Manager before that, but because of trademarks, it was trademark concerns. It was changed. The name was changed to CMAC. And by the way, it's getting some long-awaited support recently, and that's a good thing. So let's first bring up our cluster without the compiled connectors. We still didn't build anything, right? And let's see how we can interact with our cluster. So in order to bring up the cluster, what I do is go and either I write Docker Compose app or click on this button here, and it will bring up the entire stack. And we see here that everything was deployed successfully. We can see now, we'll see that the services are up. It will take a few seconds for everything to stabilize, but let's check in. Let's switch now to Postman, and let me explain something. So the way that Kafka Connect allows people to interact with it is through a REST API. The REST API is actually well documented, and let me show you the documentation. And it's important to know that it's there, because in some cases well, it's not this. Okay, so with the REST API, which is well documented here, you can see all the REST calls that you can make to the cluster in order to interact with it. So what I did before this session is I prepared some of the most common REST calls in Postman, just to show you how it works. So the first call we can make to our cluster is just a call to the port, to the main root, to the root file system of the REST server, and just get its version and a Kafka cluster ID. Then we can invoke it and tell him, give us all the connector plugins that are loaded into the server. Okay, now what you see here, you see that both connectors that I've implemented, because I didn't run the Docker Compose build command before I brought up, and so my images, which are stored on my machine, still remember the connectors, even though they are not in the folder that I've just showed you. So this is my bad. I should have run Docker Compose build before running it up, and then these two connectors will not be there. Then we can run and see if we have any active connectors that are currently up. We see that we don't have any active connectors. We can request a specific connector's information, write its name here, and get the configuration that he has and how many tasks and all that. Then we can request the tasks of a specific connector and the status of a specific task. We can also we can create new connectors, we can update them using put, and we can delete them. We will do all these operations after we implement our first connector. I don't want to do it right now. We'll do it after we write some code and deploy it. Okay, so let's get back to IntelliJ. Which for some, yeah. Okay, so we have our cluster up. Let me take it down for a second because I want to show you that we don't have the connectors. And I wanted to have a good starting point, a fresh one. Sorry, I didn't do it before the talk. So it takes a few seconds.
While you do that, maybe it's a good like checkpoint to see if there are any questions or something like that.
Yeah, okay. Excellent. So let me take some questions now.
If you want to ask anything, you can just unmute yourself, folks.
Yeah. So, Kobi, I wanted to ask something about, you talked about it earlier, the JSON converters.
Yep.
So I'm using the Python implementation of the Kafka producer, specifically the Confluent one.
Yeah.
And for example, there I'm using, I don't know, like a string serializer for the key, just an example, and a JSON serializer that I'm kind of implementing that has like the schema registry and everything connected to it.
Yeah.
So I don't have to change anything, I think. I just have to say it's a JSON converter, and by the way, here's the schema registry, right?
That's when you are working with the schema registry. I don't know if you were in the beginning of the talk, but I said that working with schemas is a topic on its own. If you guys want, I can give a follow-up session, but just in general, you should know that including the schema within each message has an overhead. And that's why people are working with schema registry and tools like that to reduce the overhead and also to manage the evolution cycle of schemas. But it is true, what you just said is true to working with the specifics of Confluent. You just specify the rest, you just give it the schema registry address and that's it, and specify the name of the schema. And then when it goes to the schema registry with the new schema, it is registered. And if you are specifying the name of a schema that he knows, then he will retrieve it from the schema registry.
Okay. So I think Itai, for you maybe. So I think a follow-up session on schema registry would be cool. We need to think about when and how, but
okay. We can talk about it in the end. Okay. Okay. So now what I've done here is while we were talking, so I ran a Docker Compose build operation to make sure that I refresh my images to represent the fact that I do not have any compiled connectors. And I want to make sure that it is represented in Postman. So I'm asking Postman now, is the fresh cluster up? Yes. You can see that the cluster ID changed. And now I'm telling him, can you give me your available connectors? And yes, and you see the connectors that he has now are only the official connectors that are shipped with Kafka Connect. We don't see any connectors any custom connectors here. Okay, any more questions before I proceed to the implementation of a custom connector? No questions? Okay, so I'll continue and you'll get the chance to ask more questions later. Okay, so once we have a fresh cluster with no connectors in it, or it may have connectors that we already deployed, but let's say that we want to implement our own connector. So what I created here is a multi-module Maven project. Why is it multi-module? Just because I want to run, to manage everything in it with a single Maven command. So I made sure all you see here is that it has two modules. It has a source connector module that I wrote and a sync connector module that I work. Let's focus on the source connector for now because it will be the vast majority of this talk. And if we have time, we'll talk about the sync connector. So I took the liberty of choosing the topic for this connector, and I defined it as we want to write a source connector that takes all the links from a specific web page, a web crawler. So if we go to a website, let's just make sure we all understand what we're doing. If we and this is the site that we are going to go to. We are going to go to engadget.com or whatever. Then my source connector, his task is to do the following. It's like he did right click and view page source. And then I am looking for all the links within this page. I want to know all the hrefs. I want to collect all the links that are in the source code of this page. I want to collect this one and this one. I want to collect all the clickable links that this page has. Okay, this is a task that is it's very common for web crawlers, but I want to do it. I want to do it from within Kafka Connect. I want to have a scalable cluster that can manage as many web crawling requests as I need it to, and I want to be able to scale it up and down per my needs. So the first thing we are going to do when we are implementing a connector, any connector, whether it is a sync or a source, is to extend the base class from Kafka Connect. And the Kafka Connect shipped API comes from an artifact called Connect API. It is an official release of it comes with every version of Kafka increments its Connect API, and we're using the official package. We'll also use two more dependencies. So we'll use JZAP, which will serve as our HTTP client to get web pages. You can use something else if you want to, but I'm going to use this friend here, and the HTTP client I'm not using anymore. So that's a redundant part. So we are going to implement a connector, a source connector. This is the name that we gave it. And in order to implement him, we are first extending the class source connector, which comes from the official package of the Connect API. Now, before we continue, I want to remind you from here, from the slide, just a second. Not this one. This. So these represent tasks, okay? Because in Kafka Connect, tasks are the functional part of the connector. The connector itself is responsible for configuring tasks and the degree of parallelism we expect from this connector. But the functional part of a connector is a task or many tasks. So what we are going to do here, the purpose of the source connector is to define at the end, eventually, to define what task classes we're going to instantiate, how to configure them, and to what degree of parallelism. And then when we start them, we are going to relate to this configuration. And that's it. That's the purpose of the connector class itself. It's to configure tasks. That's what it's responsible for. And the task itself will do the work of actually fetching data or writing it or calculating it. So let's see what we are doing. Let's go method by method and see what we need to override. So when I'm extending the source connector, you'll see that the first thing that the first method that I have here is a declaration of my task class. Here I'm telling the connector, when you instantiate, you are responsible for tasks of this type. And in our case, it's a web page links source task. When you are created, you are responsible to create tasks of web page links source task. This is your sole managed task. So when Connect calls on this connector and tells him what class are you implementing, and then he says, I'm implementing this class, which is here, and we'll see it shortly. The next thing that the connector does is configure tasks. So what he does here is creating an array list. And when I'm saying he, I mean the connector, but I wrote this code. You as developers or data scientists will have to implement this code per your need. So I'm telling the task all the configuration he needs in order to do his job. Everything he needs to know will be passed from a single instance of a map. We are passing properties to it. Why do we have an array list here? That relates to the max tasks property. Max tasks is an integer which tells the component what is the max degree of parallelism that he is allowed to run in. Each task is instantiated in a new thread. Kafka Connect will, a worker of Kafka Connect will create a thread per task. So this number that we have here is the maximum. You as developers have the freedom to supply configurations up to this number. You can give less, and then your connector will run at max. Let's say that you have a max tasks of 10, but you you make sure in your code that you do not provide more than 5 configs. Then you will never get to the degree of 10 tasks. You will get at max to 5. We'll see it when we run the samples. So here I'm creating configurations, one map per task, and adding it to the result of the task configs method, which the connector provides to the worker. So the worker knows through the connector how many tasks he needs to deploy in the worker group. After and the task configs is connected in not directly, but it is connected to the config.def method, the config method, which returns a config.def class, and you'll see that the config.def here we are defining. That's our way of telling the Connect cluster how to validate the configuration we passed into the connector. So here we can define that this connector receives a URI to analyze, which is this is the property, how it will be. This is the property key, how we will represent it in the request we send to the Connect API, and we can tell that the type of this property, if it has a default value or not, what's the significance of it, from the importance of it, from if it has to be mandatory or not, and the description to display in case in case you want to present it in the UI as done in several commercial products. So this config def is for the configuration of the connector, and then we can read per task the configuration this task needs. So we also provide the version of the connector, which comes from, you'll see it also in the API. And eventually we get to the most interesting part, the actual work that the connector is supposed to do. So just before that, we have a start and stop for the connector. So, and in the start operation, what we do here, I'm just writing a message to the system out. I remind you, I'm working with FileBit to collect the logs to Elasticsearch and then Kibana. And this practice has helped me a lot, but you can also use a logger and configure the logger as you wish. What I'm doing in the start is I'm taking all the connect properties and copying them into private members to help me then use them in the task configs. So I'm copying the URI to analyze, the web page that I want to crawl, and the name of the output, topic, which you'll see how I mention it, how I give it to the actual, how I'm telling the worker where to write in which topic to write the data. We'll see it in the task. And in the stop method, what we have is basically, I'm just writing here, just writing something to the console just to know that it was invoked. You'll see these logs shortly when we run the connector, and then you'll see it in the log, and you'll understand. Okay, we now switch to the task itself. The connector is instantiating tasks, and as I mentioned before, we extend the base class, which is called source task, and then we have to implement the following methods. We have to implement the method version, which returns the version of the connector itself. You see, I'm instantiating the connector and calling on its version. And then I have a method to start the task with the configuration with a single instance. You remember here, we created a list of configurations, a list of maps, but a task only gets a map, not the list. He gets a single member from the list of maps. So a task is configured with one item from the set of configurations that the connector provided it. And this is a good point just to stop and make sure we all understand this, because parallelism in a connect, in a custom connector, parallelism is defined by what we do here in the task configs in the connector itself, not in the source task, but in the source connector. When we get the task configs, it is our responsibility to split the work among tasks, but we have to do it for Connect. Connect doesn't know exactly, he doesn't know the strategy to use to parallelize the data we are getting. He doesn't know it. We just invented something. We invented a web page link source connector. How will Connect know how to distribute the load of how to properly cut the data and pass it into tasks? So for example, if I had here a URIs to analyze in the plural, and I would have done something like this, and now sorry, not here, but if I passed in the value, when I'm feeding the connector, the configuration, if I passed multiple websites, then here would be the proper place to make multiple configurations, not with a single URI to analyze, but with splitted URIs to analyze, and that will make sure that each task is configured with one web page. And then when we get to the task, then the task would receive all the properties it needs to do its part of the entire job. Is this point clear, or do you want me to try and clarify it more? Does anyone have a question about how Connect distributes the work between tasks? Okay, no question. So I hope that after the demo, by the way, it will be clearer. So okay, so when I'm starting the task, when the task is started, and what I'm doing is the following things. In start or in stop, the task is expected to allocate resources. Okay, so when we are running start, we are expected to allocate all the resources that this task needs. When we are calling stop, the task is expected to release all the resources that it created. Okay, it's very important to understand. If you have something to create, if you, for example, in my start, what I'm doing here is writing a log to the console. I'm saying, hey, I started, and then I'm reading my my configuration into private members. I'm reading, this is the URL that I'm going to analyze. This is the output topic that I'm going to write to. And I'm going to write to this source partition. I will explain what a source partition is. And then eventually I'm doing resource allocation. I am creating an HTTP client behind the scenes by using gzap. It connects to the URI, and then I can do GET requests against the web server and get the data and do whatever I want, and parse the links and pass them forward to the worker. And so after I was invoked by start, somebody called me. It was the worker, by the way. It's not just a somebody. The worker called me. He said, hey, start a task with this configuration. Just a second. There's something in the chat? Max task. Yeah, hey Omer, I'm going to answer these questions in the coming demo. I have a demo for it, for changing the num tasks, and we're going to do it. Okay, so start, we allocated our resources, read our configuration, and then comes a call to poll. Poll, in a source task, the worker is telling me, he schedules me and says, hey, call poll. I want you to go and get data from your source. He doesn't know the source. That's why our interface is a source record. This is a Connect API class. Source record is something defined by, it's a strongly typed type from the Connect API. I am expected to go get whatever data I have and put it in a source record, so that Kafka Connect will be able to go and take the polled data and pass it forward to Kafka. And he gives him a list of source records, and Kafka knows, according to this list, how to create the messages and to which topic to deposit them. So we still didn't mention the name of the topic. So let's see what we are doing in the poll. Poll is invoked for us. We do not, we implement it, and we expect Kafka Connect through the worker to call us and tell us, give us data. When he calls us, what we're going to do is the following. First, we instantiate the result set. We create a list of source records which we are expected to return. Then I'm going to the website. I'm actually using the connection I started. Just, sorry. Sorry. So I have an HTTP client open, a connection. I have a connection object which was instantiated, and then I'm telling him every time I'm polled, I'm telling him go and get the website that we defined here. Go and give me the HTTP document. Once I got the HTTP document, I'm taking a timestamp and saying this was, why am I taking a timestamp here and not within the writing into Kafka? Because I want all the messages which were taken from a crawling instance, a web crawling time. I want them to have the same timestamp so that I could later query on this data as a key. So I'm saying, give me the page returns to me, and then I'm taking all the href elements from it by using the select of this JZAP library, and I'm getting an elements object. This returns now. This contains the information that I want, but the information is not in the format that Kafka Connect is expecting. Kafka Connect expects to get a list of source records. He doesn't know anything about HTTP elements or URIs. He doesn't know what it is. So I'm iterating on the elements, and this is the part where I am using the knowledge that I have about the integrated technology. If I'm integrating with a web server, then I need to know that I'm going to get HTTP elements, or in this case, it's already, each element is already a link, and it is my responsibility to pass this knowledge into the result set, which is a list of source records. This is the part where I'm going back to the domain of Kafka Connect. So I'm looping over the elements, I'm iterating over it, and then I'm getting each element, and per each element, I need to create a source record and add it to the result set, okay? And at this point, once I added the result into the result set, this is the last, this was the last time that my task had anything to say about this specific technology. From this point forward, Kafka Connect doesn't care about this specific technology anymore. The result set will be passed to the worker, and the worker will deposit the data according to what I wrote in the source record. And let's take a look here what happens, what we put inside the source record that Connect can relate to. So the first thing we put in a source record when we instantiate it is the source partition. Now, the name is a bit tricky because we call it a partition and we are in the world of Kafka, but the source partition is basically the source partition is basically an object. I'm calling it an object because it's a map in which I can say everything I want about my source. I can say, for example, this can be a key, and the key will say, I came from web crawler version 3. Or I came from Redis topic, Redis cluster this, and version that, and this was the URL to get to the server. In here we are placing the data about the source that we came from, and when someone at the back end is trying to read this data, he might use this data as to decide how to move forward with analyzing the data that we have. So the source partition is something that we can put whatever we want in, as long as it's in the form of a map. And it is supposed to contain data that represents the source we came from. The source offset, and also, and again, it's the terminology of Kafka, but is the source offset is anything we want to say about how to know within the source partition where our location is. So the source offset can, for example, represent if the source partition was, let's go back to the Redis example. So if we were in the domain of Redis and a specific collection, so the source offset would say, if I came from a Redis server and the source collection was called X, the source offset will be something that the third element from the top, and then it could be the fourth element from the top and the fifth element from the top. We decide how to represent the offset within our source. It's a way of us knowing where to go back to in case we had a failure. This is not Kafka offset and this is not Kafka partition. It's important to understand. Where is it Kafka? Here. The output topic name tells Connect in which topic to put the data we are now giving it. He will take, the Connect worker will take the list of source records, iterate through them, and put each one in the topic you mentioned. In our case, it's the same topic. In our case, we are writing all of our records into the same topic. Then we define what the schema of the key is, and we'll see what happens when we see the output. You'll understand. You'll understand. You'll see what happens there. We are telling Kafka, your key that I'm going to give you now here. This is the key, the source records key. It is represented with the string schema. Okay. The same thing for the value. I'm giving you a link. This is I took from the element. I took the value of the href. I took the link itself that we found in the HTTP page, and we wrote it as a string. Not that we have any other choice in this case. So I am declaring that I'm giving you a value and its schema is string, and then I'm giving you a key and the schema is string. I'm giving you a value and his schema is string also. And then we write all the source records into our result and send it back to here to once we return it, then the worker takes it and manages the records for us and takes care of writing them to Kafka. Very important thing is error handling within tasks. And here, by the way, it's not the best practice to do what I just did, to assume that the user configured the connector properly and that he passed all the input that is supposed to give you. It's not a good practice. We need to add error checks here. And we need to remember that we are working with an external technology here, which might have some downtime or anything, or bad configuration with our. We may have passed here a web page that is a URI that it doesn't exist. So we'll keep getting here 404 an exception that the page doesn't exist. So exception handling is important, because if our task continues to fail, then then the task will be marked as failed, and the connector will stop working eventually if all the tasks are failing. Okay, so at this point, I want you just to notice that we added this because we are now going to run the connector. But so I want you to notice that I've just added a system out for the result count, so that now when we run the web page links source connector, I want you to see results. And just notice that I added this system out. So in order to deploy our connectors into Kafka Connect, I remind you, we must compile them and ship them to this compiled connectors folder in the Kafka Connect folder, so that our Docker file, when we build the image, we'll copy them into the compiled connectors path, and then in our configure and run script, before we start the connector, we are configuring to add the plugin path of the files we just added. Okay. So what I need to do now is see, first of all. Okay, so we have a cluster up, and excuse me here, and at this point we do not have our connectors deployed. So I'm going to deploy now. I'm going to deploy the connectors. The way that I'm going to do it is, first of all, I'm going to take down the cluster. And then the next thing I'm going to do is run a Maven package command on this Maven build configuration. I'll show you what we have here. So this is a multi-module which says a multi-module POM. I'm telling him I want you to build this module and this module. And within the web page links source connector, I told him, sorry. I told him that I want to use the Maven compiler plugin and Maven assembly plugin. And I'm asking him that when he builds the jar with dependencies, because we have to ship all the dependencies to Connect because he doesn't have them. So I want you to build a jar with dependencies and copy it to the Kafka Connect compiled connectors folder. Okay, and you'll see that now they were created here. Both the web page links source connector and the sync connector, which we haven't implemented yet. I implemented it before, so it was shipped here. And now, after we build the project, we need to make sure to update our images. We run a Docker compose build operation, which means that now these two files, these connectors we built, were copied into the Kafka into the image, and we can now instantiate the. When we run Docker compose, now we expect to see that that we have these connectors. So let's bring our system up again. Go to Postman, see that the cluster is up. The cluster is up now. Let's see the connectors, and we see that that we have here the web page links source connector and the system output sync connector. I didn't, you know what? I'm going to show it in a minute because I want to use it. So let's see it. So just as we implemented the web page links source connector, I implemented a system output sync connector. What it does is write to the system out. So just as with the source connector, we extend a class from connect, sync connector. We configure, the connector is responsible for configuration, including the max tasks part. And the task is responsible for writing data. Instead of poll, which means get data, it has a put, which gets a collection of sync records. And what it does is simply writes it to the system out. Okay? The magic here will be, in your case, will be to write to each technology that you want. It could be to a Cassandra database, to anywhere you want, but I just created it to write it to the output because I wanted to demonstrate parallelism, which we'll now do. So we have both connectors deployed. At this point, I want to create an instance of the web page links source connector. I want to start crawling a web page. So I'm going to the connector and I'm doing the following. This is a RESTful API and I'm going to send it the following data. I want you to create a new connector, a new source connector. That's his name. The connector is a web page links source connector instance. Here is its configuration. The configuration is the connector class is a web page links source connector that we have here. This is the class of the connector. Okay, this is the class, and this is what you should look for. How does he know the class? Because you have the jar file, which we copied to the plugin path. I want you to instantiate it at a degree of parallelism, which is 1. Why? Because there is no use in in parallelizing web crawling operation when we are working with a single URI. Okay, so I'm here telling him I want you to run a single task, a single thread per each URI that I'm passing you. I'm giving you a URI to analyze, which is HTTP, World Wide Web, and gadget.com. This is the configuration that you should pass this task. And when you are creating data, write it to the following topic, to the crawled in gadget URIs. And once I do, I am sending this data to the cluster, and I'm getting a response, and it tells me basically everything is okay. He's confirming what we just did. For now, what I can do, I can go to this REST API call, and I can do a get operation on active connectors, and I see that my connector is active now. Okay, I can also request the tasks for this connector by doing a tasks REST API call, and we see that we have a specific, we have one task running, and we can also run here and ask the status of this task. And we see that it is running, and this is the worker ID, by the way. It runs on this worker. So let's see what happened. What happened here when we invoked when we created the cluster. And
Kobi, we have 10 minutes left.
Excuse me?
We have 10 minutes left, just letting you know.
Yeah, I'll show the, here is my Kibana instance. I remind you that I sent all the logs using FileBit to Kibana. We sent all the logs to Kibana using FileBit, and I'm now here going to look at the logs. And let's see if you remember here, we wrote to the, we have the result count, right? So let's go and see in Kibana if we have any results from the connector. Okay, and we see that it does return data, but let's do an auto refresh. 5 seconds. And we see that every 5 seconds, this is our time now. And every time it invokes, it brings back 647 URIs. We have to finish shortly, and I really haven't covered everything I want, but I just want to demonstrate the consumption of data. And we might have to do a follow-up, another session, but let me just show you. I'm going now to create an instance of my output connector, of my sync connector, and I'm going to configure it. I want you to write the output, and I want you to write it in a degree of parallelism, which is 4. And yes, of course, I didn't give him the, I need to give him regex. We'll have to, we'll get back in the next session. If you want to do it, then we'll get back to this point. And okay. So what I did now was I just instantiated a system out connector just to make sure that that it is because I wanted to demonstrate the output of the sync. Okay, so it runs, and we see that it runs in a degree of parallelism which is 4, which is good. And let's see if we have any output. Let's look for this. Okay, and we see that our crawler is working. We see that we have here, our crawler is working. We have tasks from 0 to 3, degree of parallelism, which is 4, and it gives us the websites, all the links that it sees. So this is, so we completed the circle. We have a source which takes data from a web page, and a sync which writes the data into our system output in a desired degree of parallelism, and we can see it here. So, but at this point, since we have 5 minutes, I have to stop now. I want to stop for questions, and I want to ask you if you want a follow-up session so that we can complete what we just did here and clarify. Because at the end I had to run a bit quicker than I desired. So I'm now open for questions. If you can unmute us, Itai.
I have a question. It's a bit more general question. First of all, thank you so much for the talk, and if you can share the code with us, that can also be super helpful.
Yeah, not a problem.
So I wanted to ask, when in general would you find yourself wanting to write Kafka connector rather than implementing just a consumer, like a regular consumer using Java or something like that?
Yeah. Okay, this is a good question. So in general, I would say that I would want to implement a connector in two main use cases. The first one is that I'm unable to work with, to open the code that I have and integrate in it a Kafka producer or consumer in a good enough version so that so that I can rely on and send my data reliably to my Kafka cluster. That's the first. But if you do have the source code, then the next reason would be that I do not want to pose a bottleneck on my shipper, on my data shipper, because if I have a component, a service that I'm now telling him, I want you also to send another 5,000 messages a second, that might not be feasible for a lot of services. So I want to decouple the. I want to take my integration layer into a separate component so that I could scale it if I need to. Is that does that answer your question, Natasha?
Yes, thank you.
Okay, welcome. More questions? Did we have here something in the chat? What is the limit number of Kafka partition? Okay, interesting. For Omer, for source connectors, no. The limit of max tasks will not be the number of Kafka partition. When will it be the number of Kafka partitions? In sync connectors. When we are implementing sync connectors, the connector becomes, generates, we have a consumer group created per this topic that he listens on. And if we have 3 partitions and we run the task and we run 4 tasks, one of them will be a zombie. One of them will not get an active consumer. He will not get a partition assigned to it. So this is a good question, Omer.
Is there any information about the costs of running different setups of Kafka Connect? So something that's extremely interesting for us. We're running Spark clusters to do some writing as consumers of Kafka, and moving to Kafka Connect. There's all kinds of reasons why to use Kafka Connect, but cost is definitely something that's relevant. So yeah. I was wondering if you're aware of anything.
Yeah, so the answer, the straightforward answer is no, there is no cost, because what we did here, we ran everything we ran here. We ran a vanilla Zookeeper, a vanilla Kafka, if you'll see. By the way, my Zookeeper, Kafka, and Kafka Connect run the same instance. It's the same download of the official version of Kafka, which is completely free for use. And then I just invoked different members. In one of them, I ran Zookeeper. In the other, I ran. So you'll see that these files here, Kafka Connect, Zookeeper, Kafka, and Kafka Connect are the base. They are the same Docker file. I just added a different configuration and invoked a different service in my configure and run. So if you are running Zookeeper and Kafka Connect, you can, and you are implementing your personal, your custom connectors, there will be no cost of cost for licenses. You will have a cost of operation.
Cost of processing, not the licenses.
Excuse me?
How efficient is Kafka Connect compared to other technologies that you can use as a consumer for Kafka?
I would say, I would say it is mostly, it is very, very efficient. It is integrated within Kafka. It is, Kafka Connect uses the consumers and producers that are from the same code base. It's not an envelope on, it is Kafka producers and consumers. The integration is very tight here.
Okay.
Okay, it is very efficient. It is, but if you look now at my machine here, you'll see that it is mostly idle. It does nothing. My machine is now running this entire cluster and polling on websites constantly, and parsing thousands of messages a second. Let me just show you here. If we go to CMark, I want to show you the Kafka cluster behind the scenes. It is working now. It is working, but you'll see that it's not working. It is working like it does. It has about 100 links and 100 messages a second. So it's not working hard at all, but it is working, and you hardly see any effect on the machine. It's very efficient. Okay, someone wrote something here.
I think Kobi will
Okay.
here. And
yeah.
now you can breathe for a second.
Yeah.
So we'll probably, we might do a follow-up. Seems like there's an interest in that. And on behalf of the entire group, I would like to thank you for doing it and for preparing it so quickly. So thank you very much.
Thank you, guys.
And, thanks for everyone who joined today.
Yeah,
see you next time.
Thank you, guys. And if you want a follow-up session, because I want a follow-up session because I want to complement, there are some things that I've done here that were very fast. And I would like to take the time, and I see there are more questions. So if you want to, then just tell Itai, and I'll complete this session, maybe 1 more hour, and we can do a lot of specific questions for your use cases. Okay,
Awesome.
I'll shut up now. Thanks, guys.
Thank you, everyone. Thanks, Kobi.
Thank you, guys. Thank you very much.